First lecture on related rates. We're probably going to break this section into two parts. We're going to talk about how to do related rates first, and then we're going to tackle some word problems and some application problems second. But we'll set ourselves up to do this with the first part. So let's talk about what related rates are. Basic concept is you're talking about derivatives are rate of change. We've talked about slopes. We've talked about tangent slopes. We now have to talk about instantaneous rate of change. So if we're taking a derivative of any function with respect to t, being time is t. So given, here's some givens that they list. Given x is equal to 2. Also given that dx dt is equal to negative 1/3. Dx dt stands for the rate of change of x. All right. Find dy dt, the rate of change of y. So much like we did with implicit differentiation, when it wasn't a simple t, we have to multiply through by its derivative, which in most cases, in the case of y, the derivative of y is just 1. Since it's not a simple t, dy dt equals power rule here becomes 6x, since it's not a simple t, times dx dt. Now we can take our givens. We can take x is 2 and plug it in for x. We can take the rate of change of x, dx dt, and plug it in for dx dt. And now we can solve just straight up math here, solve for dy dt. This is the rate of change of y with respect to t. Okay. Let's look at one more example. Say we have the equation 2xy is equal to 4. Our givens are x equals 1 and dx dt is equal to negative 2. We're supposed to find dy dt. One thing I want you to notice here is these two are variables. And since these two are variables being multiplied together, we must use product rule. So we're going to treat the first function as 2x, and we're going to treat the second function as y. And remember, we're taking derivative with respect to t. So, product rule, the first one's derivative first. The derivative of 2x is just 2. But since it's not a simple t, dx dt, times the second function, which is just y, plus the first function, 2x, times the derivative of y, which in this case, since it's not a simple t, dy dt. The derivative of any constant, such as 4, is always 0. So now, what do we know? We know that dx dt is negative 2, so we can sub it in. We know that x is 1, so we can sub it in. But we still have two variables. We still have y, and we still have dy dt. Dy dt is the unknown. Can we find out what y is? And the answer is yes. Let's look at the original function. If 2 times x times y has to equal 4, and x is 1, we can plug that in. 2 times 1 times y has to equal 4, basically means that y has to equal 2. So let's go ahead in this phrase that we just saw here, and we're going to sub 2 in for y. So instead of 2 times negative 2 times y, we've wrote negative 4 times 2 plus 2 dy dt is equal to 0. And if we solve this for dy dt, we get dy dt is equal to 4. Again, the rate of change of y with respect to t. Let's get ready for the next lecture if we can. All right. So doing some practice problems, we're going to wind up doing a lot of things, very familiar equations here. We've got the circumference equation of a circle, the area equation of a circle, volume of a sphere, and volume of a cone. All right. What we're going to try to do is we're going to take the derivative with respect to t of all of these. Now, just to point something out for you, pi is a number all the way through. However, a, r, v, h in this matter are all variables and must be treated as such. All right. So let's take a look at the first one. Now, if you want to take a quick break for a moment and then try them yourself and then go down and see, we're going to take a look. Ready? So how do we differentiate 2 pi r? Well, dc dt is the derivative of c. 2 pi is just a constant. So the derivative of r is just dr dt. So the first one is this. The second one, the derivative of a is dA dt. Again, derivative of a is dA dt, and what this means is the rate of change of the area of that circle. This stands for the rate of change of the circumference of that circle. Rate of change here, dr dt, is the rate of change of the radius of that circle. Rate of change area of the circle is equal to 2 pi r dr dt. We use power rule here. 2 times pi, drop the 2 by 1 to get r to the first power, and then multiply by dr dt because it wasn't a simple t. Let's talk about naming this guy down here. Again, we only got one variable r, so it's just power rule again. The derivative of the volume is called the dV dt. In English, what it is, it's the rate of change of the volume with respect to time. Again, this is still the rate of change of the radius with respect to time, dr dt. 3 times 4/3 was 4. Pi r, drop the exponent by 1, dr dt. Let's move on to our cone. Our cone has two variables in it, r squared and h, and they're being multiplied together. So while we can treat 1/3 pi r squared as one function, we have to understand it's being multiplied by this second function, and we have to use the product rule. Okay? Derivative of v with respect to t, dv dt. What's it stand for? It stands for the rate of change of the volume of that cone, is equal to 2 times 1/3 is 2/3, pi stays the same, r drops by 1 to the first. This is the derivative of the first piece. Since it's not a simple t, dr dt. H, simply the second function, plus the first function, 1/3 pi r squared, times the derivative of the second function, dh dt. Again, what does dh dt stand for? It stands for the rate of change of the height of that cone with respect to time, or how fast is the height changing. All right, let's look at some more involving some trig functions and some triangles. We know from algebra and algebra 2 that sine, cosine, tangent ratios look like this. I'll